This is Honors Math 3, Unit 3, Worksheet 9. We're going to go through an example. This is number 2 on Worksheet 9. Our question says, find all roots for the function with this polynomial given. I can see that this is a degree of 3, so it's a cubic polynomial, with a root of -3 plus I. So first of all, I'm going to list out my roots. Actually, we'll do this. Put this over here. My first root is given, so -3 plus I. My second root, since we know this is a conjugate pair, is going to be -3 minus I, because we know whenever we're solving imaginary numbers, at some point we took plus or minus the square root of a number, and we got plus or minus the square root of a negative number, which also means that gave us the imaginary and solution at the end. Excuse me. So the factors I can get from these two roots, I am going to set my x equal to 0. So I need to find my factor by moving the -3 to the other side and moving the I to the other side. So I'm going to add 3 to each side, and that gives me x plus 3. And I'm going to subtract I from each side, and that gives me minus I. When you add 3 and subtract I to each side, then the right side equals 0, because -3 plus 3 and I minus I equals 0. My second factor, I'm going to do the same thing. I'm going to add the 3 to the other side, so I get x plus 3, and then I'm going to add I. Both of those factors helped me to find the roots of my function, which are zeros. So zeros and roots mean the same thing, so I can set those equal to 0 in order to get my roots, which means my factors will be equal to 0 . And that's why I was able to solve for the factor. So now I have these two imaginary, or these factors with imaginary numbers in them. And normally when we factor polynomials, like this one above, we factor over the integers, which means I don't factor to imaginary solution, or imaginary numbers. So I won't have imaginary numbers after I factor this entire polynomial, which means I can get rid of my imaginary numbers by multiplying two of these factors together and seeing what polynomial this will be equal to. So I'm going to multiply x plus 3 minus I, and I'm going to multiply it by x plus 3 plus I. So you're just multiplying base times height for each of these rectangles, which gives you the area inside each rectangle, and then you'll combine like terms at the end. So at this point, if you need to stop the video to see the solutions, you should try solving on your own first, and then check your solutions after. Alright, so if you tried solving on your own, then you should have canceled out everything that were opposites, because 3i minus 3i would equal 0, xi minus xi would equal 0, and then you also want to change -i squared. If you can write it as an imaginary number, then you want to do that. So, I'm sorry, as a real number, you want to do that. So the negative is going to stay the same. I squared equals negative 1. So when I multiply a negative times negative 1, I get a positive 1. And I'm going to combine that with my 9 because those are like terms. Okay, so now I have a polynomial that has all integers as coefficients and constants. So when I factor my original cubic polynomial, this will be one of my factors. If that's one of my factors, I can divide it out from my original polynomial. So I'm going to do that. We are going to divide 4x cubed plus 23x squared plus 34x minus 10 by x squared plus 6x plus 10. When we divide that, we have 3 terms, so I know I'm going to go 3 terms in, but I also know that in order to get to 4x cubed, I need to multiply x squared by 4x. So if I'm multiplying by 4x, then my x's with the same exponent go over the top of each other. So I'm going to do 4x and then multiply it by every single term on the left-hand side. So 4x times x squared is 4x squared, cubed. 4x times 6x is 24x squared. And 4x times 10 is 40x. Those are all positive numbers because I'm multiplying a positive times 3 positives. In order to subtract the whole second row, you're going to change all of your signs and subtract each one. So 4x cubed minus 4x cubed is 0. 23x squared minus 24x squared is negative x squared. 34x minus 40x is negative 6x. And we're going to bring down the negative 10. You can notice that these almost exactly match, but these are all negative and these are all positive. So I'm going to multiply by a negative 1. And that gives me the exact thing I need. When I would subtract the second row, we're going to change every single sign, which shows that, sorry, don't put a line through that, which shows that I don't have a remainder. My remainder is 0. Not no solution, that's why you don't put a line through it, but 0. So let's show what we factored right now. First I had f of x equals 4x to the third plus 23x squared plus 34x minus 10. Then I divided or factored out, same thing, x squared plus 6x plus 10. And it left me with 4x minus 1. The maximum number of zeros I can have for this function is 3 because my degree is 3. I already knew 2 of my zeros, or roots, either way, because I was given 1, and then I found the conjugate pair to find the second one. So I only have 1 more 0 to find, which comes from this last factor. If we're finding a 0 of our function, we set our equation, we set f of x equal to 0, or f of x. And then we solve. We already know the solutions for these two are going to be negative 3 plus I and negative 3 minus I. But my third solution will come from this last factor. If I set that equal to 0, I'm going to add the 1 to the other side and then divide by 4. So my third solution is 1/4. So there are 3 roots, 3 zeros, but only 1 x-intercept of this function. There's only 1 real 0, so that would be my x-intercept. The other 2 are still zeros of the function. They're still roots. They're just imaginary solutions.